We're going to continue this series on quadratic equations. In the last video, we looked at solving for the constants a, b, and c in our quadratic equation, and we were given 3 points on the parabolic curve. In this one, it's a slight change, but it's also a very common problem. We're going to be given 1 point, and then we're going to be given either the maximum or the minimum. And with that, we're going to need to determine A, B, and C. Now in this type of problem, we're given 2 points, right? x1, y1, and x2, y2, and one of them is either a maximum or a minimum. In this graph right here, we're shown a maximum point at x2, y2, and a random point 1. And we need to use this information to determine what a, b, and c are because our quadratic y equals ax squared plus bx plus c has those 3 unknowns. So we need to solve for, we need to set up 3 equations to solve for these 3 unknowns. I'm going to walk through 2 methods in setting this up because there's 2 equations are pretty obvious, I think. The third equation, there's 2 options for us. Once we get to setting up those 3 equations, the way to solve for it is the same way that we solved for in the previous video. This first way I'm going to show you how to solve for this at a high level is looking at setting up a third point. We're going to take advantage of the fact that we recognize the symmetry, and we can see symmetry of a parabolic plane by folding along a vertical axis. So what axes do we need to fold across? Well, I know either the maximum or minimum, right? In this type of problem, in this case, the maximum. So I can draw a vertical axis, and I'm going to draw it at the maximum point. So in this case, across the x2 location, I draw a vertical axis, and I can fold. And so by doing that, I can see where this point 1 folds across this axis. So what do I have here? So I'm saying, let's do the obvious one. This third point, this y3 is going to equal y1, right? That makes sense. This is going to mirror across, okay? x3, I say is equal to 2x2 minus x1. So why is that? Well, the distance between here and here should match the distance between here and here, right? So what is this distance? This distance is x1 minus x2. So this distance will also be x1 minus x2. But what's this location then? This location would be x2 minus the difference, x1 minus x2, which is equal to 2 times x2 minus x1. And we'll see that in the example problems. Right? Once I have this third point, then I set up the exact same way as before, right? I plug in points 1, 2, and 3 into my quadratic equation, and I have 3 equations. I subtract 2 pairs, and I isolate to just a and b terms, solve for a and b with 2 equations, these 2 equations, and then once I have a and b, I plug it back into either equation 1, 2, or 3, and then I solve for c. So pretty straightforward, same thing as what we did in the last video. I said that there was another method we can use. The other method we can use is not to identify this third point. We still take advantage of the fact that I know there is symmetry and this maximum point. Whether or not you have taken a calculus class, I don't know. So if you have not taken calculus, use this first method. If you have taken calculus and you know what a derivative is, then you can use this second method. The second method is, so we take these first 2 equations by plugging in points 1 and 2, right? The maximum and that random point, just like we did before, right here. The difference is this third point, this third equation. What we do differently is we say we're going to take the derivative of our quadratic equation. So ax squared, derivative of that is 2 times ax. Derivative of bx is just b. and derivative of c is 0. So my equation is 2ax plus b is dy dx, the slope. At maximum or minimum locations, the derivative is equal to 0 by definition. So if I say x2 is my maximum or minimum point, then I can plug x2 into my derivative and equate that to 0. So 0 equals 2ax2 plus b. This will become my third equation. So using equation 1, 2, and this new third equation, I can solve for it. It's a little bit nicer because I don't need to solve for point 3, and equation 3 is already in a AB format, right? There's no C term. So I can just subtract x1 and x2, get my AB equation as my equation 4, and work with equation 3. So it's a little bit faster in that way. All right, so I'll walk through 2 example problems. The first example problem I'll solve first using the mirror method and identifying the 3 equations by identifying a third point. And then I'll do the same thing for the same problem using this derivative method. And in the second problem, I'll ask you to try to solve it in either method that you feel comfortable with. And then I'll solve it just with the derivative method. All right, so let's take a look at these 2 problems. Okay, so our current problem, I'm going to give you, just like in the last video, the final equation, just so you have something to reference, right? So our equation that we're trying to solve for is x squared plus 2x plus 3. I'm going to give you here's a graph of it. I'm going to give you the minimum point and some random point on it, right? So we have 1, 6 as my random point and negative 1, 2. So I said I'm going to show you the 3-point method first. So I'm going to identify where this point mirrors across. Okay. So what do? First, we see that at minimum, this is my axis that I'm going to have symmetry across. Then I say, all right, I'm going to mirror across that at some y location that matches the point I know. So in that case, that would match 6. So the point will be over here at negative 3, 6. So let's work it out and see if we didn't have this graph, how will we identify point 3, right? So point 3, x3, y3 is equal to, it's going to be the minimum location here, negative 1, minus the difference between these 2 values here. So 1 minus negative 1. So that would be 2. And then y3 matches y1 at 6. So this equals negative 3, 6. Right? So this is a better method than memorizing it, but obviously you could memorize that x3 is equal to 2x1, the whatever, or sorry, x2, the minimum, minus x1. Right? So 2 times negative 1 minus positive 1 is negative 3. So it checks out too. All right. So now I have, am I missing a parenthesis here? No, I'm good. Okay, so now I have my 3 points. So there's point 3, this is point, I'll call this point 1, and this one point 2. So I need to set up my 3 equations. So I'll say equation 1 using point 1. And remember this from the previous video, we're just plugging in our points into our quadratic equation, right? So this one, right? Remember, we're assuming we don't know the final form and we're trying to solve for A, B, and C. So y is 6. A times 1 squared is just A. B times 1 is just B plus C. So there's equation 1. Equation 2, I have 2 is equal to negative 1 squared A, which is just A. B times negative 1, so that's minus B plus C. And then I'll write, let me see, I'll run here for equation 3 using negative 3, 6. Okay, So I have 6 is equal to negative 3 squared a, that's 9a, minus 3b plus c. And at this point, now we're just solving with 3 equations. I can subtract any 2 pairs to create my 2 new equations with just a and b. So let's go, let's say equation 1 minus equation 2. And let's call this equation 4. So 1 minus 2 gives me 6 minus 2 is 4, a minus a, and b minus negative b, so 2b. So the a's drop out, you get 2b. So this gives me b is equal to 2. And that checks, right? So good. All right, then I'll do, let's say equation 3 minus equation 1. And this would be my 5th equation. So 6 minus 6, that gives me 0. 9a minus a gives me 8a. Negative 3b minus b, right? Yeah, so equation 3 minus equation 1. So negative 3b minus b gives me negative 4b, and the c's cancel out. Okay, great. I plug in b equals 2 into equation 5. So I get, let me change colors here. So plug in b equals 2 into here. I'll get 0 is equal to 8a minus 4 times what b is, which is 2. So 8a minus 8 is equal to 0. So the only way that's true is if a is equal to 1. And that also checks out with the equation that we have, right? 1x squared. And the last step, then we can plug in a equals 1 and b is equal to 2 into any of these 3 equations. So let's say, let's plug it into equation 2. So this gives me, let's change colors again. Where are we? 2 is equal to a, which is 1, minus b, which is 2, plus c. So this is negative 1 plus c is equal to 2. So c is equal to 3. And that also checks out. Right? So very, very similar to the previous problem that we did, except there's an additional step of identifying what the third point is. So that's one way we can solve this. The other way we can solve it, right? The other way that we can solve it still uses equation 1. So alternate method, equation 1 and 2 stay. So we can still get equation 4, which gives us b equals 2. So that's still okay, except we're gonna not use equation 3, at least not in this form. So we're not gonna solve for point 3, and we're not gonna solve for equation 3 in this way. And instead, my equation 3 is dy dx at x2, the min, is equal to 0. So I'll write up here dy dx, that's 2ax. So this is of the quadratic, derivative of quadratic, plus b, right? And again, if you have not taken calculus, skip this part, right? You don't need to do this method. We have this other method that can solve it. This method is a little bit faster. That's why I want to show you. If you know it, you can apply it. So 2ax2, right? So the x of the minimum point, which is, let's see, negative 1 plus b, right? So this is negative 2a plus b is equal to 0. So then I can plug in, let's see if okay, so I'll plug in b is equal to 2 to equation, so this is my new equation 3. The new equation 3. And that'll give me 0 is equal to negative 2a plus b, which is 2. And so this gives me a is equal to 1. So that checks off. And then after this, it's the same method, right? Once we have a and b, we can plug into equations 1 or 2 at that point. So you can see that both methods work. Okay, so let's take a look at one more example problem. Okay, so for this second problem, I'm not going to give you the final answer. I'm going to just tell you that we have a maximum point of 1, 1, and then we have some random point negative 0.5 and negative 3.5. Pause the video now and try to solve for A, B, and C using either method. Once you solve for it, then you can come back and see if you match what final answer I got. I'm going to only solve for this using the derivative method, but I will also at the end tell you how to identify the third point. So if you're able to do that, I'm confident that you can solve for that in that method too, just to double check. So press pause, work this one on your own, and then come back when you're done. Okay, so hopefully you had a chance to work through this on your own. I'm going to set up equations 1 and 2 first, and then I'm going to use a derivative method to set up equation 3. So equation 1 gives me negative 3/2 is equal to a times 1/2 squared, or a over 4, plus b times 1/2, which is negative b over 2. And I'm going to do a fractional. I think it's a little bit easier to work with. Sometimes I should have set this up as a 3/2, but we'll change that in a second. Plus c, right? And then equation 2, what do I have? I have 1 is equal to a plus b plus c, right? 1 squared and 1 times b. Great. Now I want equation 3. So my equation 3, and I'll write, let's see, let me write it right here. dy dx of the quadratic equation is 2ax plus b. So equation 3, I'll write here, is dy dx at x max is equal to 0, right? That's a definition of a maximum or minimum derivative or slope, right? So this is equal to 2 times a times 1, because of x of the maximum is 1, plus b. All right, excellent. So now I have one equation that just has a and b. That's equation 3. And then I want to combine equations 1 and 2 so that it is also only in a and b form. So I'm going to say equation 2 minus equation 1, just because the y term's negative sign here. And this will be my equation 4. So let's change colors here. So I get 4/2 is equal to a minus 1/4, so 3/4 a, b minus 1/2, so plus 3/2 b, right? Great. Now I'm going to combine equations 4 and 3. So let's say equation 4 minus equation 3. And this would be my equation 5. Or actually, let's not do that. Let me isolate b here. Let me isolate b from equation 3. I think that'll be easiest. So from equation 3, b is equal to negative 2a. Yeah, so this will be much cleaner method. So I'll say plug equation 3 into equation 4. Okay, so now I have 4/2 is equal to 3/4 a plus 3/2 times b, and b is negative 2a. Right? So now I can solve for a. So I expand this, what do I get? This is 3/4 a minus, I'll call this 6/4, 6/2 a, or this is, I can rewrite this as 12 to the 4, so negative 9/4. Let me make sure this doesn't look like an a. 9/4 a. Okay, so a is equal to negative 4 9 times 4.5. I'll rewrite 4.5 as 9/2. Right, so this is equal to negative 2. Negative 2. A is equal to negative 2. All right, very good. So I have one of the variables. Now I can either plug this in to equations 4 or equation 3. So I'll say plug a equals negative 2 into, I think it'll be easier in equation 3. And so I'll get what? B is equal, let me change colors. B is equal to negative 2 times negative 2. Right, negative 2 times a, which is negative 2. So this is equal to 4. Excellent. Hopefully you got this. Using either method, you'll get the same thing. Then the last step is plug a is equal to negative 2 and b is equal to 4 into either equations 1 or 2, because I'm looking for c now. Right, so I think it'll be easiest if we just plug into equation 2. Equation 2. And what do we get? We get 1 is equal to a, which is negative 2, plus b, which is 4, plus c. So this is 2 plus c. So c is equal to negative 1. All right? Yes. So my equation, quadratic equation that I found is y is equal to negative 2x squared, that's a, x squared, plus b, which is 4x, plus c, which is negative 1. So this is the equation I came up with. Did you come up with something like this, right? And you can always go back and check the other method, right? If you did it this way, check it with the 3 points. So what would the 3 points, what would the third point be, right? It's the same thing as what we did in the first problem, right? You've identified the maximum. That's your axis of symmetry, vertical axis of symmetry. And you move this over here. So how did we do that? We first identify this distance using the x locations. So x of the maximum is 1. X of this random point is negative 0.5. So this is 1.5. This distance, 1.5. So you need this distance to also be 1.5. So we say 1.5 plus 1, that gives me 2.5. And the y locations are the same. That's why y is negative 3.5. Right? And so that's your graph. You could use this as your third point and replace this equation 3 with the just plugging in point 3 into your quadratic equation. So you can try to solve it that way. Make sure you get the same thing. All these equations should fit with this a, b, and c because it's following on that line, right? So let's check to see if we got the right equation. The correct answer is negative 2x squared plus 4x minus 1, which we matched up with. Okay, sounds good. We'll take a look at a couple more example problems that are of similar nature.